Hi everyone, this is Fahad Mirza and welcome to my channel. In this video, I am going to show you a model which is quite cool but still I believe very early days, and it has taken me around 7 hours throughout the last night to get it working. So I am quite excited to share it with you because I haven't really slept for the whole night just due to this model, but I believe that I have sorted out a lot of issues with it. So not only I'm going to show you how to get it installed locally, I will be sharing all the commands which I have figured out in terms of troubleshooting. So what this model does is it enables you to generate 3D images from text or images, and we will be doing both. I will also be sharing with you the limitations and the bugs which are still needs to be sorted, and I give the room to this model because these are very early days and seems like quite a complex model. So first let's have a quick look at the architecture of this model, then we are going to install it, and then we will see how it works and generates those 3D images. And the opportunities are limitless. You can use it to generate game assets, you can generate you can use it to generate animations and lot of stuff. So what exactly this model is? We already have few models which are striving to generate 3D assets from text, but all of those models struggle with very slow generation and especially around poor generalization. So if you ask them to create diverse and different objects, they all struggle one way or another, and we have covered few of them on the channel too. This is where this Tencent Hunyuan 3D model tries to help. What it does is it uses a two-stage approach, and let me quickly show you that approach in a very simple words. So this is what that two-stage approach is, which tries to alleviate those issues. On the left is the first, on the right is the second stage. So what happens is that in the first stage they are using a multi-view diffusion model that efficiently generates multi-view RGB in approximately 4 seconds. These multi-view images capture rich details of the 3D asset from different viewpoints, relaxing the task from single view to multi-view reconstruction. And then comes the second stage. In this stage, they have introduced a feed-forward reconstruction model that rapidly and faithfully reconstructs the 3D asset given the generated multi-view images in approximately 7 seconds. The reconstruction network learns to handle noises and inconsistency introduced by the multi-view diffusion, and then it uses available information to efficiently recover the 3D structure. This also involves a text-to-image model or T2I model, which is Hanjian did, and that we already have covered on the channel previously, as you can see here, around 5 months back. Quite a good model. By the way, we also covered their Hanjian large model, which is the biggest mixture of expert model ever. So Tencent is really trying to do good, to do some good stuff here. I think the only thing they need to improve and badly need to improve is their documentation and provide some easy step-by-step instructions or some, or at least some guidelines so that people would be able to install it properly. That is dearly missing from their documentation. Okay, so anyway, now let me take you to my terminal and then we will start cracking on it. Before I do that, let me give a huge shout out to our good friends at Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on range of GPUs. So I'm running this Ubuntu 22.04 and I have this GPU card NVIDIA RTX A6000 with 48 GB of VRAM courtesy Mast Compute. First, let me create this Conda environment. Make sure you create it with Python 3.9. They say on their repo that you can use later versions, but they don't work at all. Only 3.9 works, and I will show you what you need to make sure in order to get it working. So let's wait for this Conda environment to get created. And then you need to make sure that you install this CUDA version, which is 11.8. No other version works. I have tried almost all of them, from the latest to the lowest one, and this combination, which I will be running on this one, this is the only thing which works, and I will share it all the commands in my blog, and I will drop the link in video's description. So let's wait for this CUDA to install 11.8. And then you would need to install these specific versions of PyTorch, Torch Vision, and PyTorch CUDA. Let's wait for it. It is going to take a minute or so. And that took fair bit of time. Then you need to install all of these and make sure that you maintain the order and you maintain the versions. Otherwise it is not going to work. So let's wait for it to get installed. It was a real pain in the back to find these things, especially these commands. And that again took around 10 minutes, but it's all done. Let's git clone the repo of Hunyuan3D-1, and then we have seeded into it. Now, one good thing is that they provide us an environment installation script. So first let's set the permission on it. But one thing we need to change in this is that we need to remove this PyTorch 3D from it, because we already have installed it. If you keep it here, it simply breaks the installation. So I have removed that line of PyTorch 3D, and now we can run it by simply doing env underscore install.sh, and it is going to take a bit of a time, not as much because we have already installed a lot of stuff. So let's wait. Meanwhile this happens, let me also introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page. It is resilient, it is reusable, and it structures the output according to the shape of your query. And I will drop the link to their website in video's description, so do check them out. Okay, so let's go back to our terminal. Almost there, I believe. And eventually all the installation is done up till this point. Now we need to download the models. In order to download models, we need to log into Hugging Face. For that, you would need to go to huggingface.co, grab your free read token, and then paste it here. You can grab that token from your profile after logging into Hugging Face, because we are downloading the models from there. And then press capital Y and login is successful. Now let's create a directory called as weights, and then we need to download the model. So there are two models which we would be downloading. As I mentioned in the introduction, first is actual this Hunyuan3D-1 model, which is being downloaded to our local directory, and the second one would be the diffusion transformer model. So let's wait for this one to get downloaded first, and then we will proceed further. The first model is downloaded. In the weights directory, we need to create another directory for Hunyuan dit transformer, which we have done. And now let's download the model in this directory, the diffusion transformer one. And it is being downloaded. So let's wait for it to get downloaded. And both the models are now downloaded, as you can see. Let me clear the screen, and now this is the time to do the inference. In order to do the inference, thankfully they have provisioned this main.py function, where you just give a text prompt, something like a lovely rabbit, and then we just run it with the destination folder and it renders the image. Now this is where you might experience some warnings and then towards the end some error. I am unable to fix them because I believe there are a lot of other dependencies, but it doesn't impact the generation, which is a good thing. So let me run it, and then we will see how it works, how it generates a 3D image from this lovely rabbit prompt. Let's wait for it to start. So early on, you can ignore these warnings. It is loading the pipeline components, all the models and stuff. First, it is doing the image to views unit model, and then this is encoder. And now it is loading the models onto our GPU. So once it is loaded, I will show you the GPU consumption. Okay, so it's, I think it is downloaded it, loaded the model. So let me take you to my local, and then so you see it is consuming just over 20 gig of VRAM. So make sure that you have that much. And it is generating the 3D image from this prompt. Let's wait for it. And then it is generating another image by removing the background. It also generates a mesh.obj file. You can use it in your 3D programs, and I will shortly show you. And then it has generated the mesh and stuff, and this is where it gives errors, where it is trying to perform this UV unwrapping. And UV unwrapping, primarily it means that where a 3D model surface is flattened into a 2D representation, which is called as texture map or UV map. It primarily contains all the surface details and colors and stuff. So this is the error you might receive too. So there are a lot of, I think, dependencies it still requires, which uh, I don't think so it's worth spending time on. But anyway, it doesn't impact the generation. So if I go up, a lot of crap is there. So if I just go up, and then it has already generated it. Let me take you to my folder. So this is a Hunyuan3D repo. In this, it has already created this outputs directory, and then there should be a test, and this is a lovely rabbit. So this is what it has created, the 3D image, and also it has created different 3D views. There you go. Looks good. Now, not only that, but you can also use an image to create a 3D image out of it. So for instance, I will run it. So instead of giving it a text prompt, I am giving it an image prompt from my local system. And this is just an image of Komodo dragons, and this is the image which I'm using. So I'm just trying to generate a 3D image out of it. In my experiments, when I was running it, I was not impressed by the quality of images. Text to 3D, yes, it was quite good, as you just saw the rabbit. So let's see, I haven't tried this Komodo image before. I was trying it with other images. I was not particularly impressed by it, but let's see, it might work this time properly. It does generate that 3D image, but quality is not good in my previous experiments. But let's see what it does this time. Let's wait for it. So it seems that it has generated the image, and then it just fails after this, but it doesn't matter really. So let's go here, and then this is the Komodo dragon. So this is the actual image, and this is what it has generated the views. So if I just make it a bit bigger, this, so you see uh, different views of the 3D image. But yeah, so some of them are good. For example, this one is okay, but I don't think so it is up to that level where we could use it as a game asset from image. So text to image really good, but image to 3D image, nah, I don't think so. But anyway, that's it guys. I hope that you enjoyed it. Let me know what do you think about this model. And as I said, I will drop all the commands in the my blog and give you the link. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thank you for watching.